Hi everyone. Today we are going to discuss about the module 5 theories of the failure. So in this module we have a different type of theories failure will be different theories. So based on the each and everything having unique characteristics for the failing condition. May some of theory to use for ductile, some of the material theories useful for a brittle materials. Okay, maximum shear stress or maximum strain energy. So this and all we are going to discuss about in this module. Okay. Okay, so we are going to discuss about the module 5, various theories of failure. And these following theories we are going to discuss about. First one is the maximum principal stress theory, maximum principal strain theory, maximum shear stress theory, maximum strain energy theory, maximum shear strain theory. So these are the theories we are going to discuss about in the module 5. So it is the course objective of the module 5 as a learner to understanding the various theories of the failure. What is the reason we are going to use a different type of the failures where it is important for a civil engineering such as those type of the failures. Okay, and learner to study the different failure theories and to learners to know the each and every theory where we can able to use because of the application point of view. Each and every theory where we are going to use that learners should understand, and based on that, as a civil engineer, we need to solve the failure related to the problems. Okay, so here we see the images, different type of the theory are explored. Okay, for some example, maximum principal stress theory, what it states. Maximum shear stress, what it says, maximum principal strain theory, and dissolution energy theory. Okay, each and every theory, what is the practical application we are going to use theory. That is, we are going to discuss about elaborately in the unit 5. What is theory of failure? We should know where is the failure. Mainly is to predict the failure of the materials. In the building and other material, we are using the different type of the materials. So we should know as a civil engineer where this type of material we are going to failure. We don't understand. Because we cannot able to expect only one load condition going to occur in the structure number. Maybe a complex or maybe a combined stresses also be possible to occur in these structures. So in that situation, as an engineer, we need to desire when a material going to fail. Because of that only, we can able to ensure the safe design of the structure and as well as the machine parts. So that will be helpful for the prediction of the failure materials. We can able to stop. We can able to safe design of the particular type of the materials. So these are the four types of the theory of failure we are going to use for in this module. First one is a maximum principal stress theory, also known as a Rankin's theory. Why we are using different person who are invented, who are discovered this theory? That's why we are going to say for the invented name also. The maximum principal strain theory, inverted strain and also theory. Maximum shear stress theory or gust and Tesla theory, maximum strain energy theory or high theory, maximum strain energy theory or Van Mises and Henry theory. So these are the people are inverted different type of theory. So this is main. All the theories mainly concentrating on the predictive failure material. It be a brittle material or a ductile material, whatever the material we can able to predict. Once if you can predict, we can able to ensure the safe design of structure as well as the machine parts of the given materials. Okay. What is the first theory? Well, the first theory is a maximum principal test theory or a ranking theory. So this theory states that failure occurs when a maximum principal stress material reach their yield as well as the ultimate stress obtained from the simple tension. What we are going to do, we are conducting the simple tension test. Okay, we are going to notify the failures. May it be material reaches to yield as well as the ultimate. Okay, that we need to consider. The statement of theory what says when the maximum principal test is becomes equal to the permissible shear stress of the simple tension. When you're conducting the simple tension, the maximum sigma max equal to sigma yield. In that situation, maximum principal stress theory or Rankin's theory is applicable. What is the basic idea of this one? Only Rogers normal stresses causes failures. Okay, mainly it is tensile stresses or compression stresses only is valid for this Rankins theory. So effect of the CS test and other tests will be ignored. Okay, what is the temperature testers and CS testers? Everything ever. Only we are going to take it into the account for normal testers. What are the normal testers? Maybe it's a compressive testers or normal testers. When the compressive tests and tensile testers are producing that number, we can able to identify where the material can able to reach. I think simple testers. So it's a failure depends upon the only normal testers. So whether tension or compression, the failure only we going to take it into account for this Rankins theory. Okay. So this is theory. So more useful for the brittle materials. What is the brittle material? Maybe cast iron, or maybe concrete. It's a glass or stone. It will be very easily break. This is a brittle material. It's more suitable for the Rankins theory. So reason what is it? So material is can mainly due to the normal tensile stress, not in the shear. Okay. Okay, so above mentioned all the materials is the brittle materials. Okay, this type of the materials is going to failure only normal test only, not in for shear. That's why we are going to consider only for a brittle material. So not even suitable for the ductile material in case of the steel or aluminium. These are material is called ductile material because ductile material fails maybe due to the shear stress. This may be a theory of ignorance. So which theory will be ignored? We cannot able to consider for the ductile materials. What are the advantages when using the Rankins theory? It's a very simple, easy to apply because we are considered only for normal stress theory. It works well in the brittle material. That's why we are not considering as a ductile material. Useful for when you are designing the primary design. How much load are acting? What is the prediction of the failure? What is the cross section? Everything you can able to use the primary investigation of the design. We can able to use for Rankins theory. What is a negative or limitation when you are using for Rankins theory? Ignore the effect of the CSS. That's why we are using only considering for normal CSS. So if you ignoring the CS test. So not accurate for the ductile material. That's why we are saying that we should not use for ductile material. We can need to use for only for the brittle type of the failure only. So it is not suitable for the complex stress condition. What is the combined stress? Okay, when you have stresses acting on the combined stress, it was a different position. We cannot able to use for Rankins theory. So finally, what we need to conclude that this Rankins theory only applicable for normal stresses. When we are conducting the tensile stress or compression test, okay, we need to identify the failure mode. Based on the identifying the failure mode, we can able to design the structure, we can able to make a machine part, we can able to dissect. So that situation, we can go for the Rankins method. What is the second theory? Maximum CS test theory. We can call for just a Testaha theory. So this theory said that the failure occurs when a maximum CS test material reach the CS test at a yield point in a simple conducting tensile test. You take the material, just giving the load for tensile stress. Okay, in this tensile set, the failure occurs the maximum shear stress of material reach their shear stress at yield point level. Okay, then we can use for this maximum shear stress theory. So maximum shear stress theory is also called as a gust theory or the Teshaha theory. Okay, what the statement says when a material fails, where the material fails, maximum shear stress equal to the shear stress in the yielding simple tension. So then we can able to use for the maximum CS test theory. Okay. So failure condition, what we equal to? Max CS test is the maximum equal to yield divided by 2. We need to consider as a failure condition for a maximum CS test theory. So what is the basic idea? The failure is controlled by the CS test, not for the normal stress. Okay, the material is when a CS test reach the critical value. Okay, we are here not about talking about the normal stress value here. CS test. Okay, when a CS test reach the critical value, the medical chart will be is. So only maximum CS test to be considered. Other than that, nothing we are not considered. So this theory useful for a ductile material. Not Rankins theory is very useful for the brittle material. This theory we are going to use for a ductile material. Example for mild steel, aluminium, copper, these are called for a ductile material. What is the reason why using for this theory only for ductile material? Ductile material useful fail for slipping the crystal planes due to the CSS. Because of CS, ductile failure, it's because of CSS only using. That's why this theory applicable only for the ductile material. So of course, Why so? Brittle material, because brittle material fail mainly due to the normal stress, not in shear. So we cannot able to use for this theory for brittle failures. So what is the advantage? It is simple, easy to apply for all the structures as well as the component. So it's a gives safe in the design and widely used for mezzanine type of the design. We can able to use for this theory. So what is the limitation and disadvantage of this theory? Slightly over conservative. So predictive failure will be very easy because we are considering only for yield theory. Okay. When compared to the other theory, not accurately emergence theory, so does not consider the effect of normal stress fully because we are neglecting, we are not considering for the normal stress, only we are using for the CS stress. So what is the final conclusion for this type of the theory? We can use for the maximum CS stress failure at the yielding point. We are neglecting for the normal stress of the failure. Okay. Next theory is maximum principal strain theory, also called as a strain variance theory. So maximum principal strain theory is to say that when a failure occurs, when the maximum principal strain material reaches the strain at the yield point in the when you're conducting the simple test. When you're conducting the simple tensile test, this material fail occurs when your maximum principal strain material reaches the say at the yield point itself. In that time situation, we can able to use for maximum principal strain theory. But this says statement says when the maximum principal strain becomes equal to the maximum principal strain yield simple tension, we can use for the maximum principal strain theory. Okay. What is the basic idea? The failure depends upon the normal strain in the material. So here we need to consider only for strain, not for the stress. They consider the effect of the Poisson ratio. So each and every material having a Poisson ratio. What is the Poisson ratio? Lateral strain by linear strain you can get for Poisson ratio. We know that each and every material having a own Poisson ratio that being applicable for this theory. So based on the strain rather than the stress. That's why we are not using for any normal stress or the CS stress. We are considering for the strain for this theory. So this theory most suitable occasionally used for the brittle materials, not for ductile materials here also. So not to be useful for ductile materials, rarely used for a practical design. We are not considering using for this type of the theory because not give the accurate results most engineering materials. So we are not considering for this type of the theory. So it will be a advantage is a simple concept, very easy. It includes the effect of the lateral strain because of the Poisson, because we are considering strain. Okay? Strain. So this lateral strain and linear strain we are considering. So this and that Poisson ratio also will change. So it will be effect of the Poisson ratio. It should reflect to the this theory. It's a limitation rarely used in the practice. It will be not accurate when complex test conditions. Okay? Along with the normal stress, CS stress and continuous stress is applicable for the material. So we cannot able to conclude that this type of the theory. So cannot able to use this type of theory where using for complex condition. So we cannot able to predict failure correctly for many materials. So that is a limitation for this theory. Fourth is the maximum strain theory, or we can also call it the Benjamin height theory. When you're conducting the simple tensile test, the failure occurs when your total strain energy, when your total strain energy per unit fall on the material becomes equal to the strain energy, equal to strain at the yield point. That is called for your maximum strain energy. What is the statement says? The material fails when the total energy per unit wall reaches strain corresponding to the yield and a simple tension constraint. What is the basic idea for this test? Failure is maybe depends upon the elastic strain energy stored in the material. So when each and every material having energy strain energy that is in the store on the. So both the normal stress as well as CS stress will be contributed to this type of the failure. So this type of the energy also deforms only for stress or this strain. So this type of the failure is the most useful for the theoretical studies, rarely used for engineering practice. This study you can use for the ductile materials only. So it's not suitable for the brittle materials. The brittle materials is very easy to contribute to failure. So we cannot able to use for this type of the failures. The reason is not accurately predict failure for most engineering materials. So advantage of this theory based on the sound energy principle, where we can use for this type of use consider for all stress in the component we can able to use it. In limitation, not accurate for the practical design. The predicts failure too large. Okay, so that is mean unsafe for some of the cases. So rarely recommended for engineering application. This type of the theory we can able to use. So last theory is maximum restoration theory or one necessary theory. When you're conducting a simple tensile stress, okay, that failing of yielding is when occur per unit volume, material reach the restoration energy per in yield point. That type we can able to use this type of the theory. This method is a more accurate and widely we can able to use the theory for a ductile material and the brittle materials. So, what the statement says of the theory? When a yield and distortion, that means shear energy, equals to the distortion energy corresponding to the yield stress in the simple tension. So, what is the basic idea? Total strain energy. What is the how do you write in the total strain energy? Volumetric energy plus restoration energy. So yielding is caused mainly distortion, that is the shape changes. When you apply the tensile stress, the shape will be changed. So in that time, we can able to use this type of the theory, not by the changing in the volume, only for changing the shape. Okay. So failure, it depends upon the shear deformation energy in the material. So mathematically, how we can able to write for sigma 1 and sigma 2, each and sigma 1, it's a yield stress in the temple tension. Okay. When you're conducting the simple tension test, simple tensions, we can able to see the sigma 1 and sigma 2 and sigma 3, which is in various different type of the stresses. So this test is the most applicable for the ductile material only. That means the steel, aluminum, copper. So this of the type of the material only we can able to use for this type of restoration theory. So reason ductile material mainly due to the shear restoration will be happen, which theory is a more models will be more accurate. So this theory not suitable for the brittle materials. What is the advantage of this theory? So it's a more accurate when compared to the all theory of the failure and reliable theory for the only for ductile material. We cannot able to use for the brittle material for this theory. So we can consider the considering the combined stress. So this is only method we can able to use for combined stress. That's why in previous slide also we have seen for the sigma 1, sigma 2, sigma 3. So these are the various stresses acting on the body. So this type of the theory only applicable for the combined stresses. You see all the considering theory we cannot able to use for combined stresses. So while you use it when you considering machine design, when you structural design, pressure vessels and structural steel, especially steel design in finite element analysis. So these are the things we can able to use for maximum distortion theory. What is the negative when you're using for this theory? Slightly more mathematically complex. Because why the complex? Because we are considering for the combined stresses, sigma 1 and sigma 2, sigma 3 combined stresses. Also complex in the mathematical problem. So not useful for brittle material. So we can use only for ductile because same energy distortion will be happen. We cannot able to use for the brittle material. Only we can use for ductile materials. So overall theory, we are considering the module 5. What is the outcome? As a learner, to identify the suitable failure of theory, when you are designing the structure, when you're measuring the mechanical component one, we need to understand the different type of theory. Okay, each and every theory you can say that maximum theory or yield point theory is sometimes the theory of failure will be happen for a yield point or maximum point brittle material or ductile material. Some of the theories are we are not using for the only for normal stresses, we cannot able to use for shear stresses. Some of the theory says for only we can able to use for combined stresses. As a learner should understand the while designing the structural point of view or machine point of view, you need to understand different theory where it will be applicable each and every application point of view. So when we can able to understand, we can able to calculate the different stresses producing on the structure. So now we can able to learner can differentiate between the type of the material and behavior of the material. It should be a ductile or it's a brittle. Then we can able to discontinue and we can able to apply for this theory. So based on the theory, based on the giving the derivation, we can able to solve the more numerical problems also for in the based on on the theories. Okay, so we just very important things. Various theory describes the whether it's useful for the brittle material and ductile material. What type of the stress? Some of the theory only for simple tension and simple compression. Some theories is described for the combined stresses. Okay, that is only we are discussed for this module. So this module also we can able to use for strength of material. Okay, bunch are elaborately given 5 different failure modes. We can able to refer this type of the books. Okay, thank you, learners. So just we are closing for module 5, theory of the failures. We are discussed about the different type of the failures. What is the advantages? What is the reason? And what is the disadvantage? What is the limitation? Where we can able to use the civil engineering point of view. We are discussing the elaborately. So next module we see the one by one problem how to solve the using the different equation and all. Okay. Thank you very much for the passionately listening of the our modules. Thank you. Thank you all.